Okay, we're doing a bit of work today out of the textbook on estimating. I think this is a really important topic because a lot of things that we do in maths are generating estimates, and we can be misled to thinking that mathematics is all about the answer, the exact number, when in a lot of cases we don't actually know what that is. So you might get on the computer on the internet and look at a population counter and think that that is watching the numbers go up and down, but mostly up, think that that's a true value when all it is an estimate. And by similar means, like, we don't know how many fish are in the sea. We can estimate those things, and there's some errors around those estimates, but we never know the exact number, or we never know how much water is in the reservoir or something like that, for instance. So we have ways to approximate, and we make decisions about how many digits we want to know with a certain amount of accuracy. So a lot of this work, you'll see some instructions in there saying round to the nearest 10 or the nearest 100 or the nearest 1,000. This is a good chance to use the approximate sign, the two squiggly lines that you'll see me use quite a bit. They're conveying a message, and that message is, this is my best guess. And I think rule of thumb, if you like, is that we like to be within plus or minus 10% of our answer. So here's a bit of fun, and I just think it's important that you understand that the estimate is my best guess. So it's a very useful technique to use, and something when you're checking your work is often the best question to ask is that roughly right? Is that approximately right? Because then you might actually pick up on some of your mistakes. So let's go through this work, have a bit of fun, and get good at rounding numbers, and also working on leading digit approximation. Okay. This video is on estimation, and I think I've talked about this sign before. This sort of curvy equal sign means approximately equal to. Approximately equal to. And I think I've talked about this before as my best guess. Okay, and we really want to be plus or minus 10% of the answer. With rounding, my little saying is 5. When you see a 5, go up to the next 10 or the next 100 or whatever you need to do. So we're going to work that out in a minute. But just for the sake of pointing this out to you, 1, 2, 3, or a 4, we're going to stay or round down, really. And whenever we see a 5, a 6, a 7, 8, or a 9, we're going to round up. We're going to go up. So just to point that out to you, I think that's important. Imagine if we had a number line and we put 0 down one end, and we put 50 in the middle, and we put 100 up here. Now, it's easy to understand if this number is 49, you are closer. You only have to, if this was you walking, you only have to take 49 steps to get to 0, compared to 51 to walk to 100. So you're closer to 0 in this case. If it was 51, then those numbers would be reversed. And if it's 50, well, it's equal distance. What do you do? Do you walk back to 0 or do you walk to 100? And everyone in the world has decided, well, let's walk to 100. Let's round it up. If you're on 50 and you've got that choice, it's the same distance either way, then we're going to all walk to 100. And that's basically what it means. All right. So let's play around with a number. I'm going to use one number here and I'm going to use it several times. Here's our number. And in brackets, look for this kind of stuff. It says the nearest 10. So what we do, this is a units column and this is a tens. Okay, so you can most welcome to draw arrows too if you like. This is the number, this is the nearest 10, and we only consider the digit to the right of that. Okay, it doesn't matter if there's any more numbers, we only identify where we've got to round to. So it said here nearest 10, so here's our tens column. We look in this case, we look in the units column. So we would approximate that to 4,140. Okay, so let's use the same number. Now we've got different instructions. We say to the nearest 100. So find the column that's holding the place value for the hundreds. We've got a 1 there. This is the only digit to consider that is immediately to the right of the hundreds column. And so this number here is going to round to 4100. That's a 4. So we're just going to round it to the nearest 100. And if you want to think about it, that as steps and how far you are away from the nearest 100, that's probably a good analogy to use. So final thing, while we're talking about rounding, I'm using the same number, and this time we're going for the nearest 1,000. Okay, let's find the thousands column. It's here. And we only consider the digit immediately to the right. So that's a 1. So this, we're going to round it to 4,000 because that's what we're told to do. It's like someone's made a decision on how close to the answer they're happy with. Okay, recording in 3, 2, 1. I've just cleaned the board and I wanted to talk about leading digit approximation. This is an important part here. We're talking about the first digit, okay? And it saves a little bit of work because we don't see those instructions to the nearest 10, for example. We just look at the first digit, and the same rules for rounding apply. So we just need to remember 5 and we'll move up. So those things are important. So let's look at a couple of examples and really check this thing out. So 63, maybe let's do this, 63 times 8. Here's a good example. Now, the leading digit here is a 6. So we only look at the digit beside it and make this decision on if it's 5 or greater, then we round up. So we're going to leave this as 60 and times 8. Well, we're already in the units column here, so there's not much we can actually do. So let's just leave this as 60 times 8 and work this out. So what I'm thinking here is 8 times 6 times 10, and that's going to be approximately equal to 480. Okay, so let's work out the actual answer, and I don't have to do much. I can just add 3 times 8 to this number. So what have we got? 3 times 8, what's that equal to? 24. And so if we add this here, we're at 504. Okay, so we're really not that far away from the actual answer. Okay, let's try another number. I might change the color of my pen here, and let's look at some bigger numbers where we can really use this technique. I'm thinking 185 times 37 might be a good one to do. Here's our leading digits. Okay, so what's this going to round to? I only need to look at the digit next to the 1, and that's going to go to 200 times, here's my leading digit, the 3. I only need to look at the digit next door, so that's going to be 440. So what does this look like? I'm just going to punch the numbers out here, and that is going to be 8,000. Okay, there's my estimate, right? So what have I actually done? And in estimating this, what I've done is created a, I'm just going to think about this as a rectangle, and I've said, well, it's going to roughly be this big, all right? So it might pay to actually work out what the actual answer is here, and I might use this area models technique here to help us with that one. So just bear with me for a moment as I do it. What am I going to say this is? This is 100, that's 80, and that's 5. And on this side here, we're going to have 30 and 7. So quickly crunching the numbers, this has got to be 3,000, sorry. This has got to be 700. 8 times 3 is 24, add 2 zeros. And what do we got here? We've got 8 times 7 is 56, add a 0, and that's 150, and that's 35. So just quickly, 3,700. What's there? That's 2,960, and this is 185. So let's add all that up. I just might set all that out again. You can see, hopefully you can see why this technique's so useful, because suddenly things have got a little bit grindy here, and we are having to do a lot of work. That's 17, add 1, 18, carry the 1. There's the actual answer right there. So the leading digit approximation is a good technique to arrive at an answer, and it's interesting. What I'm going to talk to you about next is underestimating and overestimating the answer. quite clearly in this case we've overestimated the answer. When we're rounding both numbers up, say it's whatever the numbers are. Say I'm just using an arrow here to say we rounded them up. If we do that for both of them, we are going to overestimate the actual value. Okay? Keep this in mind. Let's look at the opposite. If we round both numbers down when we're multiplying them, for example, we're going to underestimate the actual answer. So there's only really one combination left. If one number rounds up and the other one rounds down, or, I'm just going to do this just for completeness sake, but the other option is the first number goes down and the second number goes up. That combination of adjusting one up and rounding one down perhaps will get us closer to the actual answer or the actual number that we're chasing. Okay, so let's have a look at a few examples here just to help us out. Let's keep it nice and simple. Let's do 11 times 19. Now that is going to round to 10 times 20, and that is equal to 200. And what did we do? We rounded one down. We're in this situation here where that number went down and this one went up slightly. So let's just check how close we are to the answer. And I'm thinking about this as 19 times 10 is 190. Plus, what have we got? 19 times 1, which is 19. So we're at 209. Okay, so I'm thinking about 10% of this. 10% is roughly equal to 20. And how far off the answer are we? We are within 5%. Okay, we're slightly underestimated the actual answer, but we're within plus or minus 5%. So that's pretty good actually, when what we started off saying was plus or minus 10%. So let's try another one. Let's create a new number here. We've got 25 times 34. I'm just looking for one that we're going to round up and one that is going to go down. So let's have a look. This will go to 30 times 30, and that works out really good because that's approximately equal to 900. Okay, I'll just change the color of my pen here and we'll do the work and work out the actual answer. I'm going to set this up like this. I'm going to set this up as 34 and this side is 25. That's 600. That's 80. That's 150. That's 20. So what have we got? 700. I'm adding these two together. So that's 100, that's 700, 850 is our actual answer. So 10% of that is 85, and we said 900 here, so we're probably plus or minus 6% here. So that's the idea behind approximating, okay, or estimating. So final part here was just to think about, and I set some examples here, to think about what's going to happen in terms of, are you going to overestimate or underestimate the answer? How close are you going to get by this rounding one up and one down type situation. So